Module 21, we get into how fiscal policy is affected by the multipliers. We've already learned about the spending multiplier. That's how we started this unit. So we talked about how consumer, investment, and government spending all multiply relative to the marginal propensity to consume. In this module, we're going to add the tax multiplier and the balanced budget multiplier. Taxes multiply to a smaller extent because the first round of spending, all of the tax revenue doesn't get deposited. And then the balanced budget multiplier will be the equation for situations where government spending and taxes both change in equal amount, but you all have learned that government spending multiplies more. This equation will help us find out how much it actually multiplies. So we'll start by reviewing the spending multiplier. Governments know how to use demand shocks because fiscal and monetary policy both shift AD. Now we're going to be able to look at these output gaps. How far are we from our potential output? Once we know that much, we can use the spending multiplier equation to figure out how much we need to change government spending to solve this gap. To review the spending multiplier, C, I, and G are all autonomous aggregate spending changes. Remember, the word autonomous means independent. So as long as these things are the original start to this spending multiplier, any of them can be autonomous. If investment spending leads to consumer spending multiplying, then the investment spending is autonomous, but the consumer spending isn't. So the round one could be C, I, or G. And if any of them increase by $1, every dollar that's spent, some will get saved in the economy and some will spend, and that spending multiplies. The size of the multiplier is dependent on MPC, the marginal propensity to consume. Remember, we use the consumption function to average spending at different income levels to figure out the slope. The slope gives us the MPC. And then here are the equations from earlier in the unit. The spending multiplier, we talked about how it could be 1 divided by 1 minus MPC. But because MPC and MPS, when you add them together, they always equal 1. Another way to do the spending multiplier would be 1 divided by MPS. So that's the multiplier by itself. And remember, sometimes you have to solve for the multiplier, and sometimes we have to see the overall effect on the economy. So you can use the multiplier part of the equation multiplied by the spending, the autonomous aggregate spending. Remember, that can be C or I or G. So in this module, we're going to be focusing on the left side of the equation, the change in real GDP, because we need to see if the gap is $80 billion, how much government spending do we need to do to multiply to solve that gap. If the government is in a recessionary gap, first we need to measure the size of the gap. So we would use the output gap equation and look at the actual equilibrium output minus potential output divided by potential output times 100. Just to review that equation, and that'll give us the size of the recessionary gap. In this case, the current output is $500 billion below our potential. So that's showing us not only are we in a recession, but the size. So the question is, do we need to actually spend $500 billion of government spending in order to return us to our full employment potential? No. If we spent $500 billion, that amount of spending would multiply according to the multiplier that we have to know. If we spent that much money, we would over-intervene in the economy and go from being in a recession to an inflationary period. So not only would we waste money, we would create an additional economic problem. All right, knowing that our recessionary gap is $500 billion, we need to know how much government spending to do to solve this gap. If our MPC is 0.9, then the spending multiplier would be 1 divided by the MPS or 1 minus the MPC. Either way, that'll be 1 divided by 0.1 equals 10 because there's 10 dimes in a dollar. That gives us our multiplier. Now we're going to use our change the real GDP equation. How much do we need to change our output? Well, we know that the gap is 500 billion. So from the original question, we know that this is the size of our gap, and output is real GDP. We know that the multiplier is 10, and we just need to solve for the government spending. So you divide both sides by the multiplier. So we're stuck just with G. So how much in autonomous aggregate spending do we need? We need $50 billion. Now, are we adding that much in spending, or are we taking it out of the economy? If this is a recessionary gap, what would you do to government spending to increase 80? Well, you would increase it. So in a recession, once you solve for how much government spending, we're going to increase government spending by that amount. Now, what if we're in an inflationary gap? In that case, our current output could be $800 billion above our potential output. So that's the size of the gap. That's going to tell us how much we need to change real GDP to solve this problem. In this case, our MPC is going to be 0.75, so the multiplier will be 4. And I got that because 1 divided by 0.25 gives us 4. There's 4 quarters and a dollar. So now that we know that 800 billion is the size of our gap and our multiplier is 4, all we have to do is solve for the change in spending. So let me finish writing this equation. Times G. Okay, so to solve for G, we're going to divide both sides by 4 in this case. And then 800 billion divided by 4 equals $200 billion. Now, the question is, are we going to increase government spending 200 billion or decrease 200 billion? We're in an inflationary gap. So in order to rein in the spending, we actually need to decrease G by $200 billion to solve this issue. That was the end of the spending multiplier. The next multiplier is the taxes multiplier, but technically it's going to be for taxes and transfers, because both government transfers and taxes have a smaller impact on our overall economy than government spending, because their impact is indirect. If you remember, taxes and transfers are not giving households money. They're affecting their disposable income. If I cut your taxes, that means you owe me less. That does not mean that I've given you a check. If I increase the benefits possible for veterans or for Medicaid or things like that under government transfers, that's saying people can qualify for more services. It's not the same thing as giving them money. So both of these changes don't have a complete effect in round 1. So even if you cut taxes 20 billion, your round 1 isn't 20 billion, because that 20 billion is received by households. Some of the money is saved and some of it is spent. Any amount of that original change that is saved will not multiply. So the round 1 is smaller, and that's why the multiplier effect for taxes and transfers will be smaller and have a different equation than the multiplier effect for spending. Knowing that the government spending multiplies further than taxes or transfers, let's see how that's actually true numerically. So here we can see that both of them are starting with a change of $50 billion. The first column is $50 billion of G. The next column is $50 billion of government transfers. We also need to know what the multiplier is. If the multiplier is 2, then that means that the MPC must be 0.5, because 1 divided by 0.5 equals 2. So that means if the MPC is 0.5, that you're spending half of the money. So in the government spending column, if $50 billion is spent, then in the first round, $50 billion is spent. And then we have half of that, and then on and then on and then on. You could use the real GDP equation to see that real GDP equals the multiplier 2 times the government spending, 50 billion, and that gives us $100 billion here. Now, that's all well and good for government spending, but taxes and transfers don't work the same way. So $50 billion in transfers is never fully spent in round one. In round one, those benefits are received, and households are going to spend some and save some. If their MPC is 0.5, that means they're spending half. Half of 50 billion is 25 billion. That's why you can see right off the bat, the multiplier effect is much smaller. From then on, half of that, and it continues on as you would expect, but the overall effect on the economy will be much smaller with transfers or taxes because not all of the money gets spent in that original round of spending. There's two different ways to calculate the tax or transfer multiplier. The first one is similar to the equations we've seen before. The spending multiplier was 1 divided by MPS. The tax multiplier is MPC divided by MPS. So you can use those ratios to calculate the multiplier. Or if those ratios are hard, sometimes people have a hard time dividing one decimal by another decimal without a calculator. You could use the spending multiplier and then subtract 1, and that'll work out the same way. So if our MPC was 0.9, then we would have 1 divided by 0.1. Remember, that's how we would find out that the spending multiplier is 10. So if the spending multiplier is 10, that means the tax multiplier is 9. So you can use the easier equation that you already know, and then just subtract 1 from it. And now we can take the total change in taxes, or the total change in transfers, and multiply that number by 9, and we will get the total effect of the tax multiplier. Let's practice with the tax or transfer multiplier equation. We're going to use both equations just to see how both of them work and how both of them will give you the same answer overall. So in this situation, the government decides to lower income taxes by a lump sum of $1,000. That means that each individual would owe $1,000 less than they did before. When Americans' households receive that $1,000, they will save $200 and spend $800. So what would be the MPC? MPC, remember the C stands for consumption, so that's about spending. So that's going to be 0.8 because $800 divided by $1,000 gives us 0.8. Now we know that MPC plus MPS equals 1. So therefore, if the MPC is 0.8, the MPS must be 0.2. We also could look at it and see they're saving $200 out of the $1,000 they received. 200 divided by 1,000 gives us 0.2. So using the first tax multiplier equation, we're going to do the MPC divided by the MPS. So you plug in 0.8 divided by 0.2. Now, dividing decimals is not as bad as it looks because when you have a decimal divided by a decimal, the decimal places actually cancel each other out. So 0.8 divided by 0.2 is just 8 divided by 2, which is 4. Therefore, our tax multiplier is 4. We use that, the multiplier, times the change in taxes. The change in taxes was $1,000 from the beginning of the slide. So 4 times $1,000 equals $4,000. So that's going to be the overall multiplier effect on the economy. The second equation, we're going to calculate the spending multiplier and then subtract 1 to get the tax multiplier. So spending multiplier is 1 divided by MPS, so 1 divided by 0.2. That is one that we have learned the shortcut. 0.2 goes into a dollar how many times? 5. So that tells you the spending multiplier is 5, but the tax multiplier is 1 less than the spending multiplier. Therefore, the tax multiplier is 4. So do you see how this multiplier matches the multiplier that we found in the original? Either way, you're going to get the same answer. And then we just finish it up for the multiplier times $1,000 equals $4,000. So either equation, just pick whichever one that makes the most sense to you and you think you're most likely to remember. Either way, you should get the same answer. Now, the point of this, in conclusion, is that $1,000 tax cut eventually multiplies into $4,000. If you had forgotten that the tax multiplier is different from the spending multiplier, you would have seen that the spending multiplier is 5, and done, oh, okay, 5 times 1,000, $5,000. But no, it is not $5,000 because taxes don't multiply as far as government spending. In the round 1, all that money didn't get spent. Technically, their first spending was $800 that they spent. So you could also look at it in terms of their first round of spending, 800 times the spending multiplier, because 800 times 5 will also give you $4,000. So now we have 3 different ways to get the same answer, and all of them show us the tax or transfer multiplier. We have seen how the multiplier equations work for taxes. Now let's do an example with transfer payments. So here we have government transfers increased by a lump sum of $400. When Americans receive $400 more in their disposable income, they'll save $100 and spend $300. So what's their MPC? Remember this equation, that is the change in spending divided by the change in disposable income. 3 divided by 4 is 0.75. That also tells us that our MPS has got to be 0.25, but let's prove it. The change in savings, $100, by the disposable income, $400, that is 1/4, so okay, 0.25. So once we figure those two things out, for the first equation to figure out the tax or transfer multiplier, it is the MPC divided by the MPS. So how many times is 25 in 75? 3 times. There are 3 quarters and 75 cents, if that logically makes more sense to you. So in that case, our tax multiplier is 3, and 3 times the change in transfers from the original question was $400. 3 times $400 will give us $1,200. All right, the second equation, we go through the spending multiplier first. So remember, that will be 1 divided by MPC. 1 divided by MPS, or 1 minus MPC. So there we have 1 divided by 0.25. 4 quarters and $1 gives us 4. If the spending multiplier is 4, because the tax multiplier is 1 less, it's going to be 3, which brings us back again to 3 times $400 equals $1,200. So again, both equations will get you to the right answer. If you had forgotten about the tax or transfer multiplier equation and done spending multiplier, you would have come up with $1,600. So our same rule is applying, that the tax and transfer multiplier should have a smaller overall effect on the economy than the spending multiplier. There will be another level of why the effect of taxes is different from the effect of government spending. So taxes also reduce the overall multiplier effect because there are some automatic changes in tax revenue that actually have nothing to do with fiscal policy. So remember, the word discretionary is this idea that you are deciding to change things. So maybe we're deciding to cut taxes, or we're deciding to increase transfer payments. But occasionally, our tax revenue is going to go up and down automatically just by where we happen to be in the business cycle. We have a progressive tax system. That means that different people pay different tax rates based on their income level. But as incomes rise, people are going to be paying more in tax revenue because they're now at a different tax bracket. That does not mean that there has been a discretionary change, because no one actually changed the law. Tax rates haven't changed. People would just be paying more in taxes. So this progressive tax system, where people pay different tax rates based on different income levels, leads to automatic stabilizers in our economy. Before, stabilization policy is the idea that we're going to use fiscal or monetary policy to intervene in a recessionary or inflationary gap, and that would solve our problem. But We have self-correction automatically happening in the background when nominal wages change. And now we have one more thing happening automatically, automatic stabilizers. The idea is when our economy contracts, so let's say we're in a recession, that's when our economy contracts. What's going to happen to tax revenue in a recession? Are people earning as much money? Are people shopping as much? No. So tax revenue falls automatically. No one changed the law. This is just happening by itself. Well, when taxes decrease, that's going to be an expansionary effect for fiscal policy. AD would shift right. Now, what about transfer payments in a recession? Remember, these are things like unemployment benefits and food stamps and Medicaid. What do you think would happen to the revenue created by those things during a recession? Well, those are automatically going to go up because more people will qualify for the government services during a recession. And when transfers increase, AD increases. So yet again, there's an automatic thing that shifts AD to the right, an automatic stabilizer. Now let's look at it during an inflationary time period. So in that case, the economy is expanding. We have an inflationary gap. These same fiscal things that we could deliberately change are going to have some automatic effects. So during an inflationary time, this is a recovery or expansion in the business cycle. And what do you think is happening to incomes and spending during a recovery? Well, they're both going up. So when people are shopping more and earning more, their tax revenue is going to automatically increase. And when taxes increase, that shifts AD to the left. It's going to be automatically contractionary. When the economy is improving, more people are getting jobs. So the amount of people that qualify for government services, like unemployment and food stamps, will decrease. When government transfers decrease, AD shifts left. So all of these things are saying, look, we don't always do discretionary policies where Congress decides to change transfers and taxes. Sometimes these things change automatically related to where we are in the business cycle. This unit, we've talked about expansionary policies and contractionary policies. We have one more term, discretionary policies. And by the way, a discretionary policy could be either expansionary or contractionary. The idea is it's deliberate. It's intentional. You meant to do it. You might have seen something on the TV that says, viewer discretion advised. What they're saying is that make a choice, make a decision. Do you feel like you should watch the show or you shouldn't? So discretionary fiscal policy is Congress and the president saying, we are going to vote to increase government spending. We're going to vote to cut taxes. They've made a deliberate decision. That's discretionary policy. So if they decide to raise the tax rate from 5% to 6% for something, that's a discretionary change. But oftentimes tax policies are non-discretionary because the law didn't change. Taxes might still be 5%, but if the economy is in a recession and consumers are buying less, tax revenues are going to decrease automatically, and that was not discretionary. No one did that on purpose. When the economy starts to turn around and recover, tax revenue will automatically go up. But again, no laws were changed, no decisions were made, so that was non-discretionary. So it's important to be able to differentiate. Is this effect intentional? Then it's discretionary. Is it accidental or just a consequence of something that automatically is occurring? That would be non-discretionary. But again, these can all be expansionary or contractionary. We can decide to increase AD. We can decide to decrease AD. Those would both be discretionary. One more multiplier is the balanced budget multiplier. In order to balance the budget, normally the government doesn't do fiscal policy all by itself. If they decide to increase government spending, they need to pay for that in some way. And if they want things to really be balanced in the budget, they would need to raise taxes the same amount in order to offset that. So, is the budget balanced? Yes. The problem is that the multipliers get uneven because government spending does not multiply the same amount as taxes do. we know that government spending multiplies more. So which way would it shift? It shifts whichever direction G is changing. If G is increasing, it's going to shift right. If G is decreasing, it's going to shift left. Well, how much? We're going to need the new equation, the balanced budget multiplier. And this is 1 times the initial change in government spending. So if we are increasing government spending 6 million, then AD will increase 6 million. We know it'll multiply further than that, but the difference between the government spending multiplier and the tax multiplier ends up being the original amount of G. So this equation is the shortcut to getting us to the actual amount that AD will shift. So if the government raises taxes by $9 million to pay for a $9 million increase in government purchase, what is the impact on aggregate demand? So we know that AD will be impacted $9 million. Will it be an increase or a decrease of that amount? If government spending went up, that means that AD will shift to the right by $9 million. And that is the balanced budget multiplier.